today's video we want to have a look at the inverter this company has sent me to. LCD multifunction display. Because this could be the inverter we will be using for a future project. A very fun project. This is the FCHAO. Okay, so this is the first complaint, guys. From if you sell these products internationally, you should come up with a name which can be pronounced somehow correctly. I mean, if I talk to one of my friends and say I've bought an inverter, I need to be careful not to spit at them. You should come up with a name which can be pronounced internationally, like Peter. You know, make it the Peter inverter. Guys, welcome back to the off-grid garage here from sunny hot Australia. In winter time, I'm freezing to death. I have to hire up to get out in the sun because I want to test this inverter in the wild. So in the box is the inverter, a remote display, an LCD multi-function display it says, the cable for it, a very brief user manual, and 2 sets of cables. They look super tiny, 6mm it says. Quick look here at the front. We've got 2 Australian outlets. Of course they will be different if you order this from another country then. Multifunction display, power on off button, and the socket for the remote connection. We also have these 2 funny wires hanging out of the inverter here. But this is something, well, we have discussed with the company. They put it actually on this inverter. This is an RS485 output. Honestly, I wasn't aware that they actually do it. So you can read all the information from the inverter and process this data in another device. So just so in case you want to use this inverter in a stationary environment. Never seen this before. Pretty cool. On the back side we have 2 fans and the negative and positive battery input terminals. Brass bus bars and M8 terminals. The inverter has this black aluminium case all around and these orange end caps made out of plastic. This color combination looked so much better on the website as here in reality. I'm a little bit disappointed with this plastic actually. It looks fairly cheap. Well, you definitely have to get used to that. And here on the underside we have these mounting brackets on all 4 corners of the inverter. Well guys, I wanted to show you the specifications of this inverter, but it's not in the manual. I don't know which model we have here. It doesn't say anywhere. There's something on the box here I've missed. Nothing ticked. Guys, what a bummer. It seems so we have to find out ourselves. Okay, I've now connected the inverter to our 12-volt power supply, 12.8 volts. And let's turn it on. It beeps. It says the battery is full, 21 degrees, internal temperature, 230 volts and 0 watts. I like this display. That is actually pretty good. Nice one. Okay, and we have a standby power of 8 watts, around 10, 9. Why does it? Around 9 watts. There we go. Okay, let's make this a bigger. It doesn't look too bad. It's a pretty nice sine wave here. So I want to just have a quick look at the remote, at the LCD multifunction display. Okay, this turned off. This one is turned off. If I turn this one on, oh, it turns on the inverter. Oh, nice. Okay, this is exactly the same as on the here. That is exactly the same. It is the same display. It is 100% the same display. Yeah, why not? I mean, nothing wrong with that. So you can even, this one is turned off here, you can turn it on with the remote display. Yeah, I can see a need for such a display if you are in an RV or boat. That makes totally sense. Okay, so before we connect these cables here to the inverter, I just want to make some quick calculations here. So this is a 6mm, that's a 6mm. So 6mm is good for 40 amps, constant current, times 2 and times 2. So that's 160, that was easy. Didn't need a calculator for that. It's 160 amps all in total carrying capacity with the cables they are delivering with the inverter, right? And we have 4 of them in parallel. But also 3000 divided by 12 is 250 amps. The inverter can actually pull from your battery. And for that, that is a bit low, I would say. There are probably 100 amps missing, so we would need another pair of these cables to make it for 250 amps. The cables they deliver with these inverters, they are always too small. I would not trust such a cable for 100 amps continuous current. So I have now connected the cables which came with the inverter to the terminals, and on the other side to my test cable here, which I have just manufactured this morning. It basically goes from an 8mm ring lock onto a 175 amp Anderson connector. And we need this one here because I want to connect this one here to a special battery. Here comes the battery. It is a very special battery in a stainless steel enclosure here. And have a look at this front. Isn't that insane? It comes with big M10 terminals and different Anderson connectors, USB cigarette lighters, and a discharge switch. So this switch here in this battery basically eliminates the need of a resistor when you connect loads like inverters. Because you usually get a really big spark here when the capacitors charge up in the inverter. It's not nice. Yeah, we have here the Muller Energy Battery, 12.8 volts, 200 ampere hour lithium iron phosphate battery here. And they sent me this one over here as part of a kind of an industrial review, feedback, consulting project I was part of. So basically I supplied them with some feedback about the battery. You can fully take it apart and everything. Yeah, and I gave them my honest opinion, and I think they are building now a battery 2.0 with now some of my ideas included. And this one comes with a 250 amp DALI BMS with Bluetooth. I know, right? They put a DALI BMS in this battery, but you know, it's totally fine. I understand why they're doing this. There's pretty much no alternative to DALI BMSs if you go beyond 250 amps. Yeah, there is the QUCC, but then you have this relay mechanism in between and it works kind of unreliably. Anyway, let's connect this inverter to this battery. So to connect our big Anderson connector to this battery here, we turn off the discharging. Now we can just plug in our Anderson connector. And listen. No spark, nothing. And then we turn it back on. There you go, and there was no spark, nothing. And then we can turn on our inverter. Nice! How good is this function? So we can have a quick look at the DALI BMS app. Notice we've got a reflection in here. So we are at 99% state of charge. It's a 200 ampere hour battery and we can maximum discharge with 250 amps. Discharge over current 500 amps you can do. Anyway, we leave it as it is. We don't want to care about the app or the battery here. We want to care about the Peter inverter. Okay, so not sure if the Tesla adapter actually works with the inverter right away, or if we need to do the modification with the MEN link. So let's plug it in and see what happens. Red. Okay. Let's take our adapter cable in between, and we've got a green light. Yeah, this MEN adapter only links the ground cable to one of the two actives. So it makes basically one the active and one the neutral, and connects the neutral and the earth together. This adapter is only for testing purposes here when I test these inverters, these off-grid inverters. It cannot be used in any other way, and you should not, don't do it at home. All these modifications I have here, don't do them at home. This is just for testing purposes. That's why we need this MEN link adapter. I have not seen any ground, any earth or ground screw here, terminal on this inverter at all. This is the first one. Okay, so we are now charging 1100, 1200 watts. We are pulling 230 volts. Everything seems to work just fine. Yeah, and here in the app you can also see we are pulling around 100 amps now from the battery. Checking these cable connections here as well as the cables, just to ensure there's nothing getting warm, because this is all equipment supplied by the inverter manufacturer here, so it's not my own. Okay, let's ramp up the charging speed. 1.4 kilowatts now we have. 1.43 kilowatts, 1.44. That is totally fine. Okay, so far no problem. Okay, the fan has now kicked in. We've got an animation here on the display. 1.7 kilowatts around. And we go one higher, 8 amps in the car, 1.8 kilowatts, no trouble at all. How do we get more out of this? Okay, so we are pulling 170 amps now from the battery, and I'm just going to measure the voltage drop on these cables they have supplied, because they are getting already pretty warm here. 78 millivolts voltage drop we have across the positive, and another 78 millivolt across the negative. So this is another 150, 160 millivolt gone just on their cabling. Okay, I have now installed the other adapter so I can charge the car a bit faster here from this connector, and we are at 2 kilowatts at the moment, so still well within the specifications of the Peter inverter. And I probably go to 10 amps now. Go back in the DALI, and this is 208 amps now. 2.2 kilowatts we are pulling from the inverter. Nothing gets warm, both fans are on, but these cables here are my main concern actually, because they are nice and warm already. Okay, let's go 11. I think we will have a low voltage disconnect at some stage here, because we are losing so much power across these wires now. 110 millivolt we lose, and this times 2 just for the cables. So this is now with 230 amps discharge current, and we are going into a limit of this battery here as well. The DALI BMS is rated for 250, so we are discharging the battery with 2.8 kilowatts, and 2.4 are going into the vehicle at the moment here. Shall we go one further up? Let's see what happens. 200. No, I think that is the maximum we can actually. Something has disconnected, I think. Has it? I don't know. It looks like to me it is 182 amps, it says. But this one still outputs 1.9. But the DALI BMS has shit itself. The vehicle actually, the vehicle actually has throttled down because it has an unexpected voltage drop here in the power supply, and it charges only at 9 out of 12 amps, so it cannot go any higher. Yeah, so the car measures only 216 volts, but we are outputting 222 here at the inverter. And you can see it dropping down to 200 sometimes. This is when the car actually tries to pull more and then realizes there's a voltage drop and cannot do anything anymore. Not the inverter's fault, it's just my test equipment. I definitely need to upgrade that. That needs to be better. So we're still pulling around 2 kilowatts from the inverter, And I want to show you the ripple on the output of the inverter as well. So I have connected the oscilloscope again, and this is how the wave looks like with 2 kilowatt of load. That's fairly interesting to see. And we have a little bit of distortion there, but actually not too bad. There we can see it pretty good. There's a bit of a distortion, but it's actually a fairly clean sine wave, I must say, at this load. It's not bad. And look at this, we've got 232 volts in the middle of the bush here. How good is that? And I can now connect my electric chainsaw to the extension cable which runs into our inverter. And let's see, 2300 watts. No problem. So let's see if I can run our garden shredder as well with 2000 or 2400 watts. I've already plugged it into the inverter. Oh yeah, it works. Wow. 230 amps peak. Well, now it's running. Let's see if it works. It uses 44 amps now. Yeah, it does it. And guys, in one of the final tests, we want to have a look inside the Peter inverter and see what's going on. I've now removed all these screws in the front and back, and we should be able to, oh yeah, it just lifts up. There we go. Well, first impression is very tidy installation, nicely done PCBs. Very clean cabling. You can immediately see the 6 high frequency transformers, the same 6mm cable, and we've got 40 amp fuses per channel. We've got 6 MOSFETs on this side and another 6 on this side. The 2 fans on the back, the AC inductor and some AC capacitors here before we hit the what do I see here? They have hot glued in these 240 volt sockets. That does not look good. Oh wow. I hope this is not standard. I don't like this at all. Now you can see the terminals here at the back, positive, negative. Presumably this is the control board. Ah, interesting. These 2 cables they have pulled out for me for the RS485 connection are actually going inside here onto this PCB, and there's just a 2-port little connector. So this is the RS485 communication port. You can see the LCD PCB, and this one is for the on-off switch and remote control, all connected with these ribbon cables. This one is actually secured with this silicon, while this one is not. Not sure why there's an inconsistency. Here we can see the 240 volt Hall sensor. There's the cable going through, and this measures and then calculates the power output on our sockets here. Yeah, apart from that, everything seems to be fine, neat and tidy. I like it. It looks good. I just discovered this little potentiometer here, and I'm wondering if this is for setting the output voltage. So let's turn on the inverter. Come on, start. I'm taking a small screwdriver. Get this into the potentiometer, and then we turn it and see. Ah, look at this. We can adjust the output voltage here very easily with this little potentiometer. And all the way up again. Let's see how high we can get. 233. Perfect. Okay. 229 is fine. Nice and easy. And here I have opened the FCHAO inverter just to have a comparison look. And we can see very similar components here. You can see the large AC inductor, all the transformers, MOSFETs here on the aluminium cooler, and the control board. I'm not sure, maybe this one. There's some more stuff here, I don't know. This one looks a bit cleaner than this one. But yeah, while we have them here on the bench, let's get the Renogy 3000 inverter here as well. Well, this is the direct competition for the Peter inverter, but all of these inverters are 3000 watt inverters, while the Renogy inverter only comes in a 12 volt version, the Peter inverter in a 12 and 24 volt version, and only the FCHAO is in 12, 24 and 48 volt available. I always was a big advocate of the Renogy 3 kilowatt inverter here. You've seen me using this a lot in my videos, testing batteries, charging the vehicle, transferring energy from one battery into our big battery here. You probably know from some of my videos when we tested batteries here on the workbench and had the big power supply connected, I could not fully crank it up to 21 amps at 55 volts. The Renogy inverter started beeping, got a fault, stopped inverting, and the whole test was gone. It always had this alarm error light, this red light here coming up, and started beeping, and that was it. There was no way to tell what is actually going on in this inverter. What is the actual problem? Under voltage, over current, over temperature, something, we don't know. It just beeps, turns off, and then restarts after a while. Very different is the Peter inverter, because it has this even it says here it is a multi-function display. It is not a multi-function display. This one has only one function. It displays the data. There's no other function. It is a nice display though, and it gives you all the information on one view. Yeah, and the FCHAO at the top here gives you the AC output voltage and the DC input voltage, an LED display, and that's it. If there's a fault, there's an alarm LED here, and that's it. You don't know what's happening. But if you watch the display here at the bottom in this area, when we turn it on, you can actually see there's more. There. DC output, overload. There's more to display in this multi-function display, which it is not. But this one actually gives you information, what is going on, what is the error, what do I need to fix to make it work again. So I've now connected our power supply to the Renogy inverter. And when we drive up the current here to a certain point, so we are now charging with 18 amps into our big battery. Yeah, there it is. It just beeps, gives you an alarm, and that's it. The whole system has shut down now, no charging anymore. This is what happened all the time. And now it has just reconnect and the power supply is on again. So for no particular reason, this happened all the time. Okay, I'll show you something. We plugged this whole thing into the Peter inverter. Yeah, there we go. And by the way, both inverters, the Renogy and the Peter inverter, are connected to the same SFK, the Sunfun kit battery we have built ourselves here on the channel. Look at this amazing wiring, huh? This is my most powerful battery. Okay, let's start here with 10 amps as well. And we crank it up, 15, 21. No problem. The fan comes on. And we can see we are pulling 1.5 kilowatts here. The fan comes on, gives you all the information. 22 degrees inside the inverter, which we don't know if this one overheats or what the problem is. The voltage output is correct. We've got 12 volt input. This is fantastic. It gives you all the information you need to troubleshoot or to stay informed. And I really liked this yesterday when I was out there in the garden with a garden shredder. I could just have a quick glimpse onto the display and was informed what was going on with the inverter, with the battery. Amazing. I really like it. And this one is now running for a few minutes. No problem at all. No beeping, nothing. It just takes it, you know? There. 1100 watts into the big battery. Nice. We've got 18 amps outside. It is pitch black. So this is one reason I don't like the Renogy inverter not that much anymore. I'll show you something else. Okay, let's plug in our electric chainsaw to the Renogy inverter. Look what happens when I turn it on. Nothing, nothing, it doesn't even start. It freaks out, gives us a red light, and that's it. It beeps. And then after a while it restarts. Okay, now it's back. Now it's back. Look at the chainsaw here. Nah, doesn't do anything. Nothing. That's it. Okay, let's fire up the Peter inverter. And let's see what happened here. Yeah, 1100 watts. I can do this 100 times and there's no issue. And we know the FCHAO inverter does the same with the chainsaw. It runs it no problem at all, because this was the inverter I originally had installed here in the system before I got the Victron Phoenix and before the Multi Plus. So the Renogy, not capable of doing it. It beeps, it freaks out, it turns off, while the Peter inverter just works. It just works, and it gives you all the information on the display. When they contacted me a few weeks ago and said, do you want to review our inverter? I said, nah, I'm not a review channel here. And I had a look at the specifications of this inverter and said, well, this is nothing outstanding. There are no highlights, no features, which is actually outstanding to other inverters. So I wasn't a big fan of doing a review of this inverter. I said, how boring can this be, right? How boring? That's even more boring than one of the millions of 100 ampere hour lithium batteries they're offering me all the time to review. I mean, what other tests could you do with an inverter, right? It inverts, it makes AC out of DC. They couldn't give me any answers of why people should buy the Peter inverter instead of any of the other millions of 3 kilowatt inverters out there in the market on AliExpress and eBay and Amazon and everything. So what is the outstanding feature, the highlight of this inverter in comparison to all the other inverters out there? I didn't get a real answer to that. And as you have seen, there is nothing really outstanding with this inverter. And I've got the Renogy 3 kilowatt inverter, which is the best on the market. Well, at least that's what I thought. But now that I have used it for a while with all my garden tools and other equipment here, I can say it behaves a lot better than the Renogy inverter, for example. Of course, as you have just seen from these two examples, it just works. Temperature went up by 1 degree. The Peter inverter is the perfect workhorse. It runs all your tools. It doesn't complain about anything you connect to it. It gives you all the information and it just works, you know? It's a set and forget device. As I told them as well, I'm not doing a review, I'm sharing my experience here. And this is exactly the way I would use the Peter inverter here on the property. Here on my land in the bush, I would take the Muller battery and the inverter out in the bush and use the chainsaw to cut some wood for our fireplace. And as you have seen, it has done all that. Not one complaint, not one error, not one alarm, nothing. It just worked. Yet, to be honest, I have tried this with a Renogy inverter and had only limited success. The garden shredder worked, but I couldn't get the chainsaw to work. So I knew there was a problem with the high current, well, we don't know what the problem is, right? And using here the 1.2 kilowatt power supply works as well just fine with the Peter inverter. Initially, I wanted to give the Peter inverter only 2 out of 5 frogs. But after experiencing the inverter now for a while, I really have to give it a 3 out of 5. And you know from all my testing and experience sharing here, nobody gets a 5 out of 5. This is impossible to achieve. I personally think it's a good, robust device. Nice display, gives you all the information, doesn't freak out, no error messages, runs all my tools, even under heaviest load, charges the car. So, Peter inverter, why not? They also provide you with a $10 voucher, coupon, rebate, whatever stuff. I link this all down below under the video. There are links to their website where you can read all the information about these inverters and also to their AliExpress shop as well. I'm not trying to sell you anything here. You've seen I'm not pampering this device, but this is exactly how I am going to use it. Well, and if it fails at some point, you will hear it here on the channel. Yeah, guys, I think I have shared enough experience with the Peter inverter here. And because the video is already long enough, guys, thank you so much for watching. Thanks for all your support here, especially buying me a spat. You are amazing, guys. And until the next video, you stay charged, stay safe, and thank you so much for watching. See you then. Bye-bye. Yeah, last view on the Peter inverter. On the FCHAO. I mean,